Okay, so a piecewise function is just a combination of more functions, more than one function on a single graph. We're going to learn how to, 1, draw them, and 2, be able to find the domain and range, and then also look at a piecewise function and decide what the equations are from that. So it's like combining all of your knowledge from this unit into one really fun lesson, so I'm excited about it. So here we have an example of a piecewise function. We're going to draw one. And it's talking about the price of movie tickets based on your age. So if you're a child, you get a discount. And then if you're a senior adult, you get a discount. And then if you're in between, you have to pay an insane amount. And you can tell that this is definitely aged because $9 for a movie is cheap now. It's like $16 something. Especially that one with the recliner at the West Cinemark. It's like crazy expensive. So just don't go to the movies. So my age is going to be my x-axis, and then the price of the movie is going to be my y-axis. And I'm going to plot this line. So if I just have a single number, then these equations would be y equals 5, y equals 9. So y equals 5, y equals 9, y equals 650. And so what kind of lines do those make if it's just a y equals a number? A horizontal line. So my graph is going to look like 3 separate horizontal lines. However, my x-axis, these are my, what we would call domain restrictions. So that means from the age of 0 to 12, it's going to be y equals 5. Then I'm going to jump up to 9 from 13 to 54. And I'm going to jump back down to 650. So it's going to be like horizontal line, horizontal line, horizontal line. So I would suggest when you're drawing your x-axis, I'm going to tell you to count by 4s. So 4, 8, 12, 16, 20, 24, 28, 32, 34, 38. Wait, I'm not counting by 4s correctly. I just miscounted. 28, 32, 36. It would be helpful if I could count. 40, 44, 48, 52, 56, 60. And then for your y-axis, you can just count those by 1s. And you only really need to go up to 9 because that's going to be my highest one. So x-axis is going to be age, y-axis is going to be price. So if I'm going to plot these from 0 to 12, I'm going to be at y equals 5. So 1, 2, 3, 4, 5. I'm going to go all the way. I have a closed circle because that is including 12. And when I turn 13, so I'm just going to move it over just a tad. 13 to age 54, so halfway in between 52 and 56. Gonna connect the dots. And then 650 is halfway in between that, so this line right here from 55 to, I guess, infinity. Forever. Infinity years old. I'm going to draw an arrow because I don't want to put an end to an age. So that is what we call, that is a type of piecewise function. This is a special type called a step function. A step function is when they're all horizontal lines. They're not all that easy, unfortunately, but this is just an intro to kind of what it looks like. So what we see right here, this function rule, this is kind of the way that you're going to see it. Instead of in a nice little table like it says, like it has at the top, you're going to see what we call a function rule. So this is how it is written whenever we're doing piecewise functions. from now on. So we're going to learn how to read them, and then we're also going to learn how to create them based on just looking at a picture. So if there's just a number right here, that just means like y equals 5, 9, 650. These are called our domain restrictions. So these are the x values that have this function. So if I were to interpret this domain for the top one, it's from when you are born until you turn 13. So this is why there's a less than, because it's everything up until the day before your 13th birthday. Then when you turn 13, less than or equal to. So when you turn 13, you jump down to $9. When you turn 55, you jump up to $9. When you turn 55, you jump down to $6.50. So step function is just a piecewise function that is a constant for each interval. So you have a bunch of horizontal lines. That's what a step function is. We're going to start seeing ones that are not just step functions, but they have slopes and things like that. A lot of times, so there's two different ways I could ask you a piecewise function question. I could ask you to draw a piecewise function or interpret it. The second thing I could ask you to do is evaluate a piecewise function. So you're given this rule, and then I'm going to ask you to evaluate at these x values. So instead of looking at a picture, so in the last unit we looked at the picture and we looked at where x was -3 and we chose the y value. Here we don't have a picture, we just have this function rule. So the main thing that is the most difficult part of this kind of question is deciding which function does it go into, and you have to look at the domain restrictions. So when you have these x values, you must decide which function to plug into based on the domain restrictions. So if we look at number 2, x equals -3. So if I have x equals -3, is that going to go in the top function, so the 10 or the -1? The top. So f of -3 equals 10. And it's just a number, so I'm not plugging in anything. The answer is just 10. So 2 would be an example of a step function where you have two horizontal lines. Then x equals 4. Which one would that go into? The bottom one. Because I have the greater than or equal to, so 4 is included in the bottom one. So f of 4 equals -1. Okay, so for x equals -3, which one do I plug it into? Top, middle, or bottom? The top one. So f of -3 is going to be 3 times -3 minus 1. So -9 minus 1 gives me -10. For x equals 4, which one do I plug it into? Middle or bottom? The bottom one, because it is inclusive of 4. So f of 4 is 1 minus 4, which becomes -3. So what I do is I put my dashed line at x equals -1, because that's where it changes functions. Then I'll look at my domain restrictions, and next to the inequalities I write closed or open, because it helps me. So the top one is inclusive of -1, so I'm going to have a closed dot there, and then it's not inclusive at the second one, so it's going to be open. So I have closed and I have open. So everything to the left of -1 is going to be y equals 4. So I'm going to go up to y equals 4, and I have a closed dot at -1. And then it's not inclusive of 4. So f of 4 is 1 minus 4, which becomes -10. For x equals 4, which one do I plug it into? Top, middle, or bottom? The bottom one, because it is inclusive of 4. So f of 4 is 1 minus 4, which becomes -10. For x equals 9, which one do I plug it into? Top, middle, or bottom? The bottom one, because it is inclusive of 4. Probably should have used a different color. Let's see. Here we go. Close dot. And then it goes out forever to the left because it is less than -1. And then at -1, it stops. And I'm going to have an open circle at y equals -2. And I'm going to go out forever to the right because it's everything greater than -1. So open circle to the right. Then I want to find the domain and the range. We're going to use interval notation, not inequality. No, it's just to help me. No, you can erase it. You don't need the dash line. I won't grade the dash line. I just do it for my own benefit because I want to know where to start and stop.
So why? Oh, so you always just start at -1?
That's where the function changes. So at -1, it's where it goes from being y equals 4 to y equals -2.
Oh,
At x equals -1. So my domain, if I'm reading it from left to right, what would it be? Negative infinity, positive infinity. Good. Because even though at -1 it has an open circle, it also has a closed. So it keeps going. Then my range, it's 2 horizontal lines. So it looks like -2 with bracket, union, 4, bracket.
why do we have the union sign?
Because it's -2 and, it's like saying and 4.
Doesn't the -2 have parentheses since it's an open circle?
But it's also closed circles all here. So these are all closed on the same horizontal plane. Okay, we look at number 5, and this just takes practice. So I don't want you to get frustrated. It really just takes some practice and it takes some work. So your homework will be a good time. You'll have some time at the end of class to work on homework. So if we look at number 5, I have 2 different functions, but now they're linear. So it's not going to be nice little horizontal lines now. So what I'm going to do first, I have 2 domain restrictions. I have 2, so 2, and then I also have 5. So I'm going to draw, for me, I'm going to draw 2 vertical dashed lines, one at x equals 2 and one at x equals 5. Because that's where I know when to start and stop. Second step is I'm going to write open or closed next to the inequalities. So here it's open. And you can even do O and C if you want. At this function it's closed and then open. So we all should know how to graph the line y equals -3x. But something that is helpful for me is I want to know exactly what point is y equals -3x at that domain restriction. So what I do is I take this value 2 and I plug it into the function -3x. So out to the side, I'm going to take -3 times +2 because that's where my domain restriction is. So I want to know, where do I put that open circle? At that domain restriction, or at that vertical line. So -3 times 2 gives me -6. So I have an open circle at 2, -6. So I'm going to put an open circle there. Does everyone see how I got that? I just plugged in 2 into my equation. I evaluated it. So I have an open circle at 2, -6. Then my slope is -3. So that means I could go up 3, left 1, up 3, left 1. You can always plug in values. So if I plugged in -1, or if I plugged in 1, if I plugged in 1, I would get -3. So I can put a dot at 1, -3. If I plugged in 0, I would get 0. So you can just keep plugging in points, or you can graph the line, either way. I have had students that will graph the entire line, so from left to right, and then erase the part that is not included. So I've had students that have done this all the way, and then they went back and they erased, okay, well I don't need this part right here, so I'm just gonna erase it. So you can graph the whole line first and then erase the parts that don't fit the domain. You can plug in points. There's several different ways that you can graph a piecewise. Okay, and then the next one, so I'm going to graph the second function. I have two domain restrictions, so it's going from 2 to 5. So I'm going to plug in x equals 2, and I'm going to plug in x equals 5. So when x equals 2, I have 2 plus 3. That gives me 5. So the ordered pair 2, 5, would it be an open or a closed circle? Closed, because of this less than or equal to. So I have a closed circle. It is just a slope of 1, so it's like rise over run, 1 over 1, keeps going. But I can also plug in x equals 5. So 5 plus 3 gives me 8. So at x equals 5, I have an open circle at 8. And I connect the dots. But you'll also notice it's just the equation of the line x plus 3. Another thing you could do is you could graph the whole line, so all the way to the left. Some people like to graph the y-intercept first and then just count. Then you would erase the part that's not in the domain. So it is up to you. And then I'm done with that. Then I want to find the domain and range. So domain for this, if I'm reading it from left to right, would be what? Negative infinity, reading it left to right. Do I stop at 2? No. Got a closed circle, then I stop at 5. And then would that be parenthesis or a bracket? Parenthesis. Good. Range. My lowest point is what y value? Negative 6. Is it open or closed? Negative 6. Yeah, it's open right here. Right here, it's negative 6, so it is open. So I do a parenthesis. And then I go up, up, up. Do I stop anywhere? No, so I go to positive infinity. Good.
How did you draw the line for x is less than 2?
How did I draw the line? I plotted it at 2. So when I plugged in 2, I got negative 6. And then the line is y equals negative 3x. So it has a slope of negative 3.
Oh.
Yeah, so I'm just graphing the line y equals negative 3x, but I'm stopping at 2.
So I would, wait.
So it's like up 3 to the left 1, up 3 to the left 1. So for number 6, I have 2 domain restrictions. One is at the line x equals 0. One is at the line x equals 4. So I have 2 of them. Then I want to write next to my inequalities closed, open, closed, open. So this one would be open, closed, open, closed. So I'm going to take the first one. This is an x squared. This is a parabola or a quadratic, which you have graphed before in Algebra 1, but I know that it's been a while, and we'll get more practice with it later on in the year. So for now, we're just going to plot points. So we're going to pick 3 points to plug in, and then we'll just connect the dots and draw the picture. So I'm going to plot the point when x equals 0. So I'm just going to come down here. When x equals 0, if I have x squared minus 3. If x equals 0, 0 minus 3 gives me negative 3. So I'm going to plot the point 0, negative 3. Would it be an open or closed circle? Open. Good. So 0, negative 3. I have an open circle. What's another point that I could plug in? Anything less than 0? Negative 1. So let's do negative 1 squared minus 3. The negative 1 goes in parentheses because I'm taking the place of x. So when x equals negative 1, what does y equal? Negative 2, because I have 1 minus 3 gives me negative 2. So I'm going to plot the point negative 1, negative 2. What's another point that I could plug in? Negative 2. So negative 2 squared minus 3. So what would that be? 4 minus 3 gives me 1. So negative 2, positive 1. I could do one more if I wanted, but you don't have to. I'm just going to connect the dots and know that the parabola is going to keep going exponentially like that. I will not be picky about that. I will just want to see maybe 1 or 2 points plugged in. Probably 2. Yes?
Where did you get negative 1 and negative 2?
I plugged them in because my domain restrictions are everything less than 0. So I just plugged in negative 1 and negative 2 to get some points so that I could graph it. Because I want to draw my picture, I need some points to evaluate in order to graph the function. Otherwise, I don't know what it looks like. Okay, the next one is 1/2 x minus 3. So what are 2 values that I need to plug in? 0 and 4. So when I plug in 0, I get 1/2 times 0 minus 3. Because I'm plugging in my 2 domain restrictions. X equals 0, x equals 4. So when x equals 0, what is y? Negative 3. It's also in the same place as my last function. It was open, but now I'm going to go ahead and close it. So it's okay to have an open and a closed circle in the same spot. What's the next x value I need to plug in? 4. So 1/2 times 4 minus 3. That gives me what? Negative 1. Open or closed circle? Open. So at 4, negative 1, open. And then I connect the dots. The last one is 4x minus 16. What value do I need to plug in there? 4. So I take 4 times 4 minus 16. That gives me what? 0. So 16 minus 16 gives me 0. So when x equals 4, y equals 0, is that an open or closed circle? Closed. So it's kind of hard to see. I'm going to try and do that. Then the slope is what in this equation? 4. So I'm going to go up 4 over 1, up 4 over 1.
I thought we would do it backwards.
That was because it was a negative slope. This is a positive slope. That goes on forever.
So how do you know when to like which direction to like stop? Like how come like you don't make that line go down?
Because it's for every x value that is greater than 4. So it's going to the right. Yes. Whenever I had a less than, so here, I was going to the left. So you have to think about, is it values to the left of that number or to the right? And that's either a less than or a greater than. Okay, then the domain and range. So domain, what would the domain be? Negative infinity to positive infinity. There's nowhere that has just an open circle. My range, so what's my lowest y value? Negative 3, would that be a bracket or a parenthesis? Bracket. And what would my highest value be? So negative 3 to what? Positive infinity. Good. Okay, the last type is we're going to actually create a function from this. So it takes a few steps, but this is the best way that I can explain how to do this. the first thing, I always create my domain restrictions first, and then I go back and do the equations of the lines. So I'm going to draw a vertical line at my domain restrictions. Got 4 of them. So if I'm taking this little interval here, I'm going to go back and erase this, but you draw your little squiggly. It's always fun to draw your little fancy bracket. Then you're going to have like a place for your function, and then this is going to be where your domain restriction is. And there's going to be 1, 2, 3 of them because there are 3 functions. So if I'm looking at my first domain, so the step that I have highlighted in green, if I were to put that in inequality notation, because that's why we learn both, because domain and range is an interval, but piecewise functions are inequality, unfortunately. So if I were reading the green shaded area, what's my smallest x value? -6 is less than, and then that's a closed circle, so it's going to be less than or equal to. No. I just drew, you don't have to draw the boxes. I just did that to leave some space. So -6 is less than x is less than what? 4. -3. So you have a closed, open, closed, open, closed, open. Okay, now let's look at the next shaded area. So my next domain restriction, it starts at what? -3, and it's closed, so less than or equal to x, and then it stops at 4, and it's an open circle, so it's just less than. Then I look at my last shaded area. It goes from 4 is less than or equal to x is less than 8 because it's open. Okay, now we've done the hard part, in my opinion. Now we just need to go back and figure out what the equations of the lines are. So in order to do that, I'm going to erase all of this. In order to do that, we need a slope and we need a y-intercept, okay? So if it helps, you can take each line and extend it out. So find the slope. So if we look at the left one, 1, 2, 3, 1, 2, 3. So the slope is 3/3, which is just x. If this kept going, so if I go up 1/1, up 1/1, up 1/1, the y-intercept would be at what? 7. So my equation of the line is x plus 7. Do you kind of see how I got that? So you can draw on this picture. You can extend it out. That's fine, because we're not doing anything with the picture. I'm grading this stuff. So if you want, extend it out so you can see where the y-intercept is. Because when you're finding the equation of the line, you need 2 things. You need a slope and you need a y-intercept. Okay, the next one is just a horizontal line. So that would be just a constant number. Y equals what? 2. Good. So I just put a 2 here. And then the third one, this one is a negative slope. So if I'm doing rise over run, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2. So that slope is what? -2x. If I want to extend this out, keep going, keep going. It doesn't fit on the picture, but if you counted, what would you get for your y-intercept? Because you would go 2 here, which is 12, 2 here, which would be 14. So plus 14. And then you are done.